So, discrete random variables. Discrete means that it can be just these three integer values. That's it. You have these three choices. That's a discrete random variable. Now let's say we have the situation where we can bet on this spinner. It costs $2 to spin, and you win the amount of money that's on here. Okay? You either get your money back, you lose $1, or you get $3. Now, what we would do with this is we might say, well, what is our expected value if we played this game lots and lots and lots of times? So that's like, what is our average take on each spin over the long haul? So let's take a look at what that might look like if we organize the data. Okay, let's do this. So here I made a little chart, and notice that all the probabilities have to add up to 1. I think we're kind of used to that. So the way we do this called expected value, and a lot of times they call it the mean of our random variable. We're just going to call this random variable x, right? So that's our random variable. It could be 1, 2, or 3. What you do is you multiply your value times a probability, value times probability, value times probability, and add them all together. That is going to be your mean, or expected value, what we expect to get on average per spin. Okay, let me multiply this out and show you what it looks like. Okay, there it is. So we expect on average to get $2.3. Now I know it doesn't land on a 2.3, but that's over the long haul. If we spun it many, many, many times and divided by how many times we spun, we would come out with, essentially, we get $2.30 each time we spin. So we're actually winning, right? Because it only cost us $2 to play. Okay. So the notation for this would be mu of x. It's the mean of our random variable is 2.3. Okay. So, of course, you probably know what's coming. It's got to be standard deviation. So what's the high and low of how far we could be off from our 2.3? Okay, does it vary widely? Is it very, very chaotic, I guess? Or is it close to that 2.3, right? We can be very consistent in what we think we're going to win. Okay, so let's take a look at how do we do the standard deviation. So what we do is, if you remember, take our value, how far is our value away from our average? And we basically find out the average of our distance away from the mean. Okay, so let me write that out. Take the value, how far away is it from our mean? Okay, here we are. And if you remember from way back, some of the values are going to be negative, so we square them. So we square all that stuff. Now instead of adding them up and dividing by 1 less than how many we have, this time a little bit of a shortcut is just take that value and multiply it by its probability that it happens. So each one of these gets multiplied out by its probability, like that. And that's all there is to it. It is the value right here, the value minus the mean, square it, multiplied by the probability. And you do that for all those numbers. So let me do that, and I'll show you what it looks like. So all that stuff multiplied, squared, added together gives us 0.61. So that's the standard deviation of our random variable, which is 0.61. So that's the variance, and don't forget the last step, take the square root of that. Oops, you know what? I did that wrong. This is the variance. Let me rewrite that. So the variance is equal to 0.61. And then to get the standard deviation, you take the square root of the variance. That gives us 0.78 approximately. Okay, so this is how far we would be off. We would have on each spin an average of $2.3 and plus or minus about 78 cents. So still, I think it is a good bet on that one. Okay, so that's an example of a random variable and expected value and the standard deviation. Whoa, that's a lot of stuff.